Welcome to today's class. Today's class is set number 13 and it is continuation of class number 12 and carboxylic acid. And in the first class it was introduction of carboxylic acid and I went on solving the lot of question answer on introduction of carboxylic acid, and today's class is specifically on preparation. And sorry for distortion of the sound. My sound is a bit distorted. It will create a problem for this. I am tremendously sorry for this. So preparation, before starting preparation, let me just remind me of some of the facts so that you can go on solving this one within a minutes or second. First of all, K2Cr2O7 KMnO4 is the strong oxidizing agent, and Jones reagent is very famous, you should know. Chromium trioxide CrO3 plus sulfuric acid, it is also oxidizing agent, and another is tolerance and failing. These are mild oxidizing agent. And K2Cr2O7, you keep it in your mind that if there is OH, it changes into COOH on applying K2Cr2O7 or KMnO4 in acid media or H media. Jones, if you apply CH2OH, if you with Jones reagent CrO3 plus sulfuric acid, again CH2OH will become CHO. And tolerance and Felix reagents are mild oxidizing agent. You know that if it is CHO, then CHO converts into COOH. Now, on preparation of carboxylic acid, on which compound we get carboxylic acid, first of all, before starting the class on preparation of carboxylic acid, let me just talk about something background of this so that you can very easily solve out all the questions answer of entrance exam. First of all, you see there are two types of reagent used in the whole preparation in your textbook of carboxylic acid. One is KMnO4 and K2Cr2O7. These are strong oxidizing agent, and another is Jones reagent in CrO3 plus sulfuric acid, and another is Tollens reagent and Felix solution, and these are mild oxidizing agent. So what is the function of K2Cr2O7 and KMnO4? It is very simple. When you get CH2OH, it will directly convert into COOH if you assume KMnO4 or K2Cr2O7. Acid chloride COCl COX, acid halide or acyl halide, whatever you name it. On acid hydrolysis, you will get carboxylic acid. On amide acid hydrolysis, you will get carboxylic acid. Or acid anhydride on hydrolysis, you will get carboxylic acid. Or ester on acid hydrolysis, you will get COOH. Or if it is toluene, CH3 groups will alkyl KMnO4 will convert into COOH, and there is a fact I will tell a bit later. And if there is cyclic compound and there is double bond, if you assume it KMnO4 in acid, then it will be COOH and COOH. And if it is not acid in, it is a neutral media, then it will be OH and OH. These are the some factors. If you know it, so you can very easily understand all type of conversion. So let me start with the solution, how we'll prepare this laboratory method of preparation of acyl chloride. So now let me talk about acyl chloride. So your acid is RCOOH. If you can understand where from acyl halide has arrived, then we'll use this method to convert it. This is asked in the entrance exam. So laboratory method of preparation of acyl chloride. So what is acyl chloride? Then that is OH group is converted into into RCO. OH is replaced into chloride, means this is acyl chloride. So acyl chloride on hydrolysis we get carboxylic acid. Am I right? But here the fact is it is correct. Acyl halide, acyl chloride on hydrolysis we get carboxylic acid. So this is acyl chloride. So acyl chloride is the derivative of carboxylic acid. If OH is replaced by Cl or chlorine or bromine, then it is called RCOCl, acyl chloride. So laboratory method of preparation of acyl chloride. How will you prepare this acyl chloride? So you have got the preparation of acyl chloride, and lots of ways are there, but laboratory method means profitable way without any consuming time or without any less effort in a big amount. If you can get acyl halide, then it is called laboratory method of preparation of acyl halide. So are you not getting RC double bond O? We should replace this one. So in case of alcohol chapter, you have got when alcohol is there, alcohol react with PCl5, PCl3 or SOCl2 to get OH replaces Cl. So it will help this concept of the previous chapter of alkyl halide or aryl halide. You got OH converts to Cl, RCOCl. If you apply here PCl3 or PCl5 or thionyl chloride, and thionyl chloride is an important compound where this converts into this. In turn, we will get uh, another product which is water, which is HCl, which leaves out from the reagent. So it is a profitable way in which we can prepare acyl chloride. So here in the option SOCl2, PCl5, PCl3, lots of things are given. Sorry, we use acyl thionyl chloride to get acyl chloride. Acyl chloride. Next question is now acetic acid manufactured by fermentation of, we need to get acetic acid. What is acetic acid? It is CH3COOH. So this acetic acid is manufactured by fermentation. Whenever there is a question of fermentation, unit there should be ethanol, CH3CH2OH. So this is acetic acid manufactured by fermentation from answer ethanol, because CH2CH converts to COOH on acetobacter is an oxidizing agent. So acetic acid manufactured by fermentation from answer is ethanol. So ethanol converts to on oxidation CH3COOH, and acetobacter is the organism which acts upon this one and oxidize CH2OH into COOH. Next one, again in different classes, I have already mentioned acetylene when reacts with H2SO4, HgSO4. You see, this is acetylene. If you write it in this way, this is acetylene reacts with sulfuric acid and HgSO4, very famous reaction. And this is H positive and Hg positive. Symbolically, you can write it in this way. What we get here is A and B. Answer, what is A? Means here water and H positive get attached to it. So in which carbon OH and H plus will add? It is all the same, because both the carbon is symmetrical, having same number of hydrogen. So either place we can use HCOH double bond CH and one H. One H is here and OH is here. So this is your A. So what's happened is a unstable one. So it changes its position in this way. So what we get here is HC double bond O C HHH CH3. We are getting aldehyde. So if you can follow my previous class, I told you that the trick of acetylene reacting with HgSO4 and sulfuric acid, you just add up in this way. H2 will get attached to that carbon which has more number of hydrogen, or OH will attach to that carbon which has less number of hydrogen and no number of hydrogen. So since here carbon containing both on both sides of triple bond are same hydrogen, having same hydrogen, so whatever the way you add up H2 and O is here or O is here, H2 is here, H2 is here, it is all the same. So you add H2 and here O, your answer is CH3CHO. CH3CHO. This is the shortcut way, and then if you use the long cut way, you can use in this way. Next one is CH3Cl Cation is this CH3Cl. If you use Cation, very simple, this Cl CH3 will become Cn. Am I right? And if you acid hydrolyze it, water, I have already written here, cyanide Cn on acid hydrolysis always give you COOH. So Cn on acid hydrolysis give you COOH. So on acid hydrolysis, this will give you CH3 COOH. It is simple rule, you follow this one. And third part is when it is acting upon ammonia, if you now add up ammonia, what's happened? Ammonia has lone pair of electron, so it is base in nature, and this is acid in nature. Am I right? So if it is acid, this is plus and this is minus. Am I right? So that part will get attached with this one. Lone pair will get attached to this is minus and this is plus. So you are getting CH3 C double O NH3, and this hydrogen is getting attached with this NH3. So you are getting NH4, thereby it is going to be becoming positive. So CH3 C double O NH4. So on heating, what will happen? On further heating, what we get here is there will be loss of water. Just you lose one water molecule H2 and O here. So you are getting NH2 here and one O is here. So remaining CO, this is CH3. You are getting CH3CO NH2, and this is the answer of the question number 5. Next one is benzyl alcohol oxidized with KMnO4. What is benzyl alcohol? This is benzyl alcohol KMnO4. So very often I told you CH2OH upon oxidation with K2Cr2O7 or KMnO4, it becomes directly COOH. So this CH2O which will convert into, so your answer acid, am I right? So benzyl alcohol oxidized with KMnO4 will give you benzoic acid. I have already. Very simple reaction. You just arrange it. You will find the idea. CH3, CH3, C double bond O. And this reaction is very common, you know. There is ketonic group, CO is there and CN is there. You are getting CN. So it is nucleophilic addition. So this CN will attack here and bond will be withdrawn. Answer CH3, CH3, C. Cn is coming here. O is negative and this is plus and this is minus. This O negative will get attached with H positive. So we are getting cyanohydrine complex, cyanohydrine compound, cyanohydrine. This is cyanohydrine. And one step more, you are asked acid hydrolysis. H3O positive means acid hydrolysis. So already we have mentioned CN and acid hydrolysis give you COOH. Very simple. So you CN will become, other thing will remain same. You will get, this is the answer. So CH3CONHCl will give you A. This is your A. A on acid hydrolysis give you B. This is B. First one is very simple, nucleophilic addition, and second one is hydrolysis. And CN on hydrolysis give you COOH. Answer is this. A liquid was mixed with ethanol and a drop of concentrated sulfuric acid was added. A compound with fruity smell was formed. Your hint is fruity smell compound is nothing but ester. What is ester? Ester means there will be C double O group. We need to get a compound with which having C double O H, C double O group, and in the both side there will be RR, maybe alkyl, maybe aryl. So if this C double O group is there, then it will be ester group. So a liquid was mixed with, we don't know this liquid. So when this is mixed with ethanol, ethanol means C2H5OH, and a drop of concentrated sulfuric acid, concentrated acid is formed, a fruity smell from compound was formed, then this liquid is nothing but it is an acid. Acid and alcohol, whatever acid you use, because it is not mentioned what is the type of ester is formed. I have assumed here this acid plus alcohol, concentrated acid, you are getting, this is CH3, C double O, and you add up this part here, C2H5. So you are getting this compound which is nothing but an ester, sweet smelling compound. And what is that compound? Your compound not given is an acid, maybe ethanoic acid, maybe propanoic acid, maybe other type of acid. That is, it must be organic acid. So product obtained on interaction of phenol with sodium hydroxide and carbon dioxide. This is a very important question. This is phenol, and when it is treated with sodium hydroxide and carbon dioxide, what is the major product formed? Answer, so So come to the next question. Which one of the following does not give benzoic acid on hydrolysis? First one is phenyl cyanide. First of all, what is the question you see? Which one of the following does not give acid on hydrolysis? The compounds are which one of the following? These are the following. This is phenyl cyanide, this is benzyl chloride, and this is benzoyl chloride, and this is methyl benzoate. If you cannot write this formula, you can't answer this one. And you are asked which one of the following on acid hydrolysis will not gives benzoic acid. So one thing you see here, it is called benzoyl chloride. This is benzoyl, benzoyl, benzoyl chloride, and this is called benzyl chloride. When there is yl, benzyl, then with benzene there should be carbon and must have two hydrogen. Then it is called benzyl. And if there is a benzene ring and there is a carbon, and if this carbon does not have any hydrogen directly attached with this carbon, then it is called benzoyl. And if the benzene which is attached with carbon which has one hydrogen, this is called benzyl. So two hydrogen benzyl, no hydrogen benzoyl, one hydrogen benzyl. So one example of benzyl is benzaldehyde. Say benzaldehyde. So one hydrogen and this is CHO, benzaldehyde, one hydrogen benzyl, and no hydrogen, it is benzoyl chloride, carbon, no hydrogen, benzoyl chloride, benzoyl chloride, benzoyl, two hydrogen, CH2Cl is benzyl, OH is there, benzyl alcohol, Cl is there, benzyl chloride. So this is the way. If you can't write this formula, you can't. So what's happened here is, let us see whether this gives on acid hydrolysis. What happened? Acid hydrolysis, acid hydrolysis, acid hydrolysis, acid hydrolysis. Whether they will this product will give you the benzoic acid or not. Here, this is cyanide, CN group. CN group on hydrolysis gives COOH. It will give you benzoic acid. Am I right? It will give you. And forget about this one. So benzoyl chloride, COCl. I have told you, if it is COCl, acid hydrolysis give you COOH. So here again you are getting benzoyl chloride will give you this, and this is ester. Am I right? COR and phenyl group, COOR. Ester on acid hydrolysis give you acid and alcohol. So here also you are getting COOH in this type. You are getting H. Here there is OH. So in three cases we are getting benzoic acid, but here we are not getting benzoic acid. So the answer is that benzyl chloride on acid hydrolysis will not give you acid hydrolysis. So answer this one. You need to know these things, otherwise you cannot answer this thing. Yes, next question is very important. You see, you are given bromobenzene react with magnesium and ether gives on carbon dioxide reaction. This reaction is very, very important. Carbon dioxide is there. When there is a question of carbon dioxide, there is carboxylic acid. Keep it in your mind, because there is Grignard reagent is there. So Your question is simple, bromobenzene, and you are asked to treat with magnesium with ether. So this will give you this is Grignard reagent RMGX. Here R is phenyl group, RMGX. Your A part is over. This is A. And when you get Grignard reagent, I told you earlier, RMGX, always this part is plus and alkyl or aryl part becomes minus. So here MgX, this part is plus and this aryl part is minus. Am I right? Then you are asked carbon dioxide and water hydrolysis later on. So this is a very important reaction. When carbon dioxide is made to react, say this is your carbon dioxide. Am I right? So this is carbon deficient. If bond is withdrawn in this way, this is partially positive center, and this positive center and this negative will get attached with this one. Am I right? So negative will get attached here and this bond will be withdrawn here. This will be negative and this negative part will get attached with this positive. So what you get here is this carbon is like this. OMG Br. This was actually minus and this minus and plus is getting attached with this and this plus is getting attached with this. So you are getting this one and this on acid hydrolysis means H plus and OH negative. Am I right? Acid hydrolysis. Always this breaks in this way. H will come to negative oxygen and OH will come to positive magnesium. So you are getting here C double bond O and here COH. I told you earlier, when there is carbon dioxide and if there is a Grignard reagent, so there is every possibility of getting carboxylic acid COOH. So we have got COOH. That is, we can write it in short COOH. So I have shown you the way how we have got this one. Simply when you get a Grignard reagent, in its place just you put COOH, your answer will be okay. If you bothers about the way how it get attached or get the result. Taking a mixture of ethyl alcohol and acetic acid in sulfuric acid gives a fruity smell compound. The reaction is, you have already seen that if it is acetic acid and this is an alcohol, we have made the reaction in presence of acid sulfuric acid, a sweet smell compound has formed and hence it is called an ester. What is the name of reaction? The name of reaction is esterification. It is very simple. This simple question was asked in AIMS. It is an esterification reaction. Next question, propyl magnesium bromide treated with propyl magnesium bromide C3H7Br. Propyl, it is alkyl halide. Propyl magnesium bromide reacted with carbon dioxide. I told you, if it is propyl magnesium bromide, it is Grignard. I told you that a bit earlier, if there is carbon dioxide, then this part simply becomes C3H7 COH. Shortcut. If there is Grignard reagent, so in place of MgBr, you just add up COOH, your answer will be correct. And if you again ask how, so the question is C3H7 MgBr plus O, this is plus and this is minus, this is partially plus, so this will get attached to here and this bond will be withdrawn here. So what you get here is with this C, the remain intact, or bond is withdrawn means negative. Along with this negative, you add up this magnesium MgBr. So negative is attacking this means it is attaching. On attack of nucleophile, it will get attached. We are getting this, am I right? So on hydrolysis means OH and H plus, am I right? So what's happened? It breaks in this way. This is negative part, this is positive part. So positive part will go here and negative part will go in opposite center. So what you are getting is C3H7 COOH. So this is the way how you get, and this is the shortcut how you will get the answer. Whatever we find easy, you write the question answer. It is very important. Very often question is asked. Grignard reagent with carbon dioxide, answer is carboxylic acid. CH3 CH2 CO NH2 with X, you are getting CH3 CH2 CH2 NH2, and you are asked what is that X, and I have not shown you the options. What is the X? X is K2Cr2O7, X is HCl, X is a lot of lithium aluminum hydride, a lot of other things. But main fact is that whatever the answer I will tell you, just you follow how to answer this CH2 C double bond, or you write in this way. You see, this is the part which is now converting into this. Until and unless you know the trick or the point upon which you can answer, basing upon which you answer, is that CO is converted into CH2, means it is a reducing reagent. Here in the option there was lithium aluminum hydride and all other options are oxidizing agent. Since it is a reducing agent, so option X of lithium aluminum hydride is the correct answer. This is the all about of today's class. Thanks a lot for watching the class. Please don't forget to subscribe the class. In the next class, I am going to start the acidity and viscidity of various type of acid, very often asked in the entrance exam.